Hello everyone, welcome to Applied Chemistry Tutorials. So today we are going to discuss about mean, median and mode of group data. Let's start with a brief introduction. So in a previous video about mean, median and mode, we have discussed about central tendency and dispersion in details. So just as a recap, central tendency is where data points are centered in a given data set, and dispersion is how these data are scattered. So there are three major ways to measure the central tendency are mean, median and mode for ungrouped data. And for detailed understanding of this, please check the link here for that video. Now in this video, we are going to discuss about the same for group data. So for group data, there are three major ways to measure the central tendency, and those are mean, median and mode, similar to that of the ungrouped data. So let us talk about mean, median and mode of the group data. So first let us understand what is ungrouped and what is group data. Let us take an example to understand ungrouped and group data. So consider 15 students in a chemistry class obtain the following marks out of 100, and the marks are shown below: 53, 63, 60, 92, 80, 80, 72 and so on. So this can be regarded as an ungrouped data, as we discussed in our previous video about mean, median and mode for ungrouped data. Now let us convert this into a group data. So first, to ease of understanding, we arrange these numbers in an ascending order. So and put them in the first row of this table known as mark obtained or xi, and so these are 42, 53, 60, etc. And in the second row we put the number of students or frequency, which is fi, and we put it here in the second row how many students obtain this particular marks. So one student got 42 here, as we can see from here. One student got 53, and there are two students who got 60, you can see here, and so on. So this type of group data is known as discrete frequency distribution. There are another type of group data. So in this case, instead of the marks obtained, we put class interval in the first row. So we see there is a range from around 40 to 100, and so we subdivided that range into several intervals. So they are 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90 and 90 to 100. Now we are gonna check which marks will fall in which category. So say number of students which belongs to 40 to 50 class interval is only 1, because one student got 42. Now one student got 53 and two students got 60. So this one student definitely fall into 50 to 60 class interval, but there is an ambiguity whether these two students will land up in 50 to 60 category or 60 to 70 category. So for that we have a rule. So if it falls on the boundary, put it in the upper class. So we'll put these two in the 60 to 70 category. So for 60 to 70 category, we have these two students who got 60 and one student got 63. So 2 plus 1, 3. Similarly, for 70 to 80 category, we have these two students who got 72 will end up here. And for 80 to 90 category, we have 4 plus 1 equals to 5 students here. And for 90 to 100 category, we have 2 plus 1 or 3 students here. So this type of group data is known as continuous frequency distribution. So these are the two types of group data. So let's talk about mean of discrete frequency distribution. Say x1, x2, x3 up to xn are the values of n quantities, and f1, f2, f3 up to fn are their frequencies respectively. Then mean x bar can be given as x bar equals to summation of fi xi from I equals to 1 to n divided by summation of fi from I equals to 1 to n. So now we have the table from the given example. So marks obtained or xi are shown in row 1 and number of students are fi are shown in row 2. Now we have to find out the term fi xi as it is shown here in this equation. So fi xi is determined as fi multiplied by the corresponding xi. So for the uh, first column, or we say the first number that appears here is 42, and the number of students who got this 42 is only 1. So we have fix equals to 1 multiplied by 42 equals to 42. Similarly, for this column we have 1 multiplied by 53 equals to 53, and for the students here, two students got 60. So 2 multiplied by 60 is 120, and so on. So now we can add all the fixi term in the numerator, and then we can also add all the fi terms in the denominator. So from calculation we will have this is equals to 73.9. So we can say the mean is 73.9. So now let's talk about mean of continuous frequency distribution. So here say x1, x2, x3 up to xn are the class marks of n class intervals, and f1, f2, f3, fn are their frequencies respectively. Then mean x bar can be given as the similar formula: x bar equals to summation of fi xi from I equals to 1 to n divided by summation of fi from I equals to 1 to n. So we got the following table from the problem shown here. So here we are having the class intervals from 40 to 50, 50 to 60, and other ranges here. And now we have mentioned about class mark here in the equation, or in the definition of x bar here. So class mark needs to be determined. So class mark is given as upper class limit plus lower class limit of a given class interval divided by 2. So for example, for class interval 40 to 50, the class mark will be the upper class limit 50 plus the lower class limit 40 divided by 2, or 45. So similarly we can have all the class marks shown here in the given table. So we already know about the number of students from the problem, so we put that into the third row. So now from this we can calculate fixi term as shown here in the equation. So fixi is 1 multiplied by 45 equals to 45 for the 40 to 50 class interval. Then 1 multiplied by 55 equals to 55 for 50 to 60 class interval. Similarly, 3 multiplied by 65 equals to 195 for 60 to 70 class interval, and so on. So we are going to add all the fixi terms in the numerator, and then divide it all the number of students or fi terms added together in the denominator. So after calculation we will have it equals to 77. So we can say that the mean is 77 for continuous frequency distribution. So we can clearly see there is a difference between the mean calculated from the same data set using the continuous frequency distribution method and discrete frequency distribution method. So definitely the method we followed in the discrete frequency distribution is more accurate, because we did not introduce the term class mark. Here for continuous frequency distribution we introduce the term class mark for ease of calculation. So for a larger data set, these two numbers will be close to each other. So now let's talk about median of the discrete frequency distribution. So here is the given table we obtained from the our problem. So marks obtained or xi are shown in row 1, and number of students fi are shown in row 2. So to calculate the median of discrete frequency distribution, first of all we need to arrange it in the ascending order. So as we mentioned, for ease of calculation we already arranged it in the ascending order, otherwise we have to arrange it. So here xi's are all given in an ascending order, you can see it from here. So now we need to calculate the cumulative frequency, or FCI. So for this first column we can say that the cumulative frequency is equals to the number of students or frequency itself. From the second column itself, so we have to calculate the cumulative frequency, which is equals to the frequency of that given column plus the cumulative frequency we obtained in the previous column. So 1 plus 1 equals to 2. Similarly, for 60 marks, we can have 2 plus 2 equals to 4. So now onwards we can have all the cumulative frequency numbers are calculated here. So for better understanding, we can say the first term here that has marks obtained 42, the second term is 53, then 3 and 4, or third or fourth term, the marks obtained is 60, the fifth term is 63, sixth and seventh term is 72, 8th, 9th, 10th and 11th term is 80, 12th term is 86, 13th and 14th term is 92, and the 15th term is 97. So as n is odd, we need to find out the n plus 1 by 2th term here. So now which is we know n equals to 15, so 15 plus 1 by 2th term, or 8th term, that we need to find out, which is equals to 80. So we can say the median is 80. Now let's talk about the concept of median class. So for continuous frequency distribution, we have class intervals, as we have discussed before. So median cannot be directly calculated from this type of table. So we need to find out the cumulative frequency first, as I mentioned in the last slide. So for 40 to 50 class interval, we have cumulative frequency 1. For 50 to 60, we have 1 plus 1 equals to 2. Then for 60 to 70, we have 2 plus 3 equals to 5, and so on. So here we can clearly say the first term falls in 40 to 50 class interval, the second term in 50 to 60 class interval, third, fourth and fifth term in 60 to 70 class interval, and so on. So first we need to find out the value of n by 2 to calculate the median class. So here n is 15, and so we can say so the term n by 2 is equals to 15 by 2, or 7.5. Second, we need to determine the nearest and greater integer than that of n by 2, or 7.5, which is definitely 8. And then finally we need to figure out the class interval corresponding to the integer value we obtain in the second step, that is 8, or 8th term, which is definitely 80 to 90 class interval. So here the median class is 80 to 90 for continuous frequency distribution. So now let's talk about median of the continuous frequency distribution. So this is the table that we obtained from the given problem. So we have already discussed about the median can be obtained after finding the median class, which is we have already figured out. So 80 to 90 is the median class here. So median can be calculated using the following formula, which is L plus n by 2 minus fc divided by f and whole multiplied by h, where L is the lower limit of the median class, which is 80, n is the number of observation, which is 15, fc is the cumulative frequency of the class preceding the median class, which is 7. Now f is the frequency of the median class, which is 5, and h is the size of the class interval, which is 90 minus 80 equals to 10. So definitely we can calculate median from the given numbers, but one thing to note here is the size of the class interval needs to be same for all of these class intervals. So when you get a large data set, we just need to subdivide it into the class intervals having the same size. Otherwise we cannot apply this particular equation. So after putting all the numbers in the given equation, we have the numbers which is equals to 81. So we can say the median is 81 for the continuous frequency distribution. Now let's talk about mode of group data. So for first we'll talk about the discrete frequency distribution. So here we already have the tables. The marks obtained xi are in the first row and the number of students fi in the second row. So we can say the mode is calculated as the value corresponding to the maximum value of fi. Here maximum fi is 4, so the mode will be 80. So we can say that the mode is 80 for discrete frequency distribution. So this is kind of similar to that of what we have seen for the ungrouped data as well. Now for continuous frequency distribution, we have the following table here, but mode cannot be directly obtained from this given table. So we need to have a term called modal class similar to that of median class, and which is the class interval with maximum frequency. Here 80 to 90 class interval represent the maximum frequency, so which is 5. So we can say that the modal class is 80 to 90 for continuous frequency distribution. Now we have the following table for continuous frequency distribution, and we already obtained the modal class which is 80 to 90. Now mode can be obtained from this given modal class. So mode is L plus f1 minus f0 divided by 2f1 minus f0 minus f2 whole multiplied by h, where L is the lower limit of the modal class which is 80, f1 is the frequency of the modal class which is 5, then f0 is the frequency of the class preceding the modal class which is 2, then f2 is the frequency of the class succeeding the modal class which is 3. Now h is the size of the class interval which is 90 minus 80 equals to 10. So similar to that of median calculation for continuous frequency distribution, the h needs to be of same sizes for all the class intervals. So we can plug in those numbers and we can have the mode equals to 86. So we can say that the mode is 86 for continuous frequency distribution. Now we have obtained the mean, median and modes for both discrete frequency distribution and continuous frequency distribution. But what kind of distribution it will be, whether it will be a normal distribution or a skewed distribution, or if it is a skewed distribution, whether it will be a positively skewed or negatively skewed distribution. To understand these differences between them, you can check our previous videos on mean, median and mode as shown here already. So for discrete frequency distribution, we plotted values in the x-axis and frequency in the y-axis. So the topmost point of the frequency curve will represent the mode, so which is 80 for the discrete frequency distribution. So we can have that values here, and for this particular problem we are having the median is also equals to 80, which shows this same point, and mean we obtain 73.9, which represents this point in the x-axis. So we can definitely see a long tail on the left hand side of this plot, so that means we are having a negatively skewed distribution. Similarly, for continuous frequency distribution, we are having mode at the topmost point of the frequency curve, which is 86. Median we obtained as 81 and mean is 77. So this also represents a negatively skewed distribution as well. So this is all for today, and please stay tuned for the next video. We'll see you soon.